everyone. Today we'll be going through chapters 2.1 of quadratic equations and inequalities. So the first thing we'd like to do is to learn how to use two methods to solve for quadratic equations. The first method would be completing the square, using completing the square method. And the second method will be using the formula for quadratic equations. Let's look at an example together to illustrate this. So let's say I'm given the quadratic equation x squared minus 1 plus 5x equals to 0. And I'm asked to solve for this quadratic equation. So what I like to do is I like to rearrange this equation to be in the form of ax squared plus bx plus c equals to 0. So to do that, let's just do a simple rearrangement. It will be x squared plus 5x minus 1 equals to 0. Then let's try using method 1, which is completing the square method. So completing the square method, alright, what you do first is if you have ax squared plus bx plus c equals to 0, I take a out, so I'm left with x squared plus b over ax plus c equals to 0. Then I factorize what's inside this square brackets. So I try to make it like this. So x plus b divided by 2a, the squared, and then minus. So what I do this will be b squared over 4a plus c, equals to 0. So make it into this form. Right, then after that it's just a simple rearrangement to solve for x. Right, so let's try to do that with this example. So since a is just 1 here, I can just simply say that this is x plus 5 divided by 2, squared, minus 5 over 2 squared, right, plus c, and c is just minus 1 equals to 0. So I'll be left with x plus 5 over 2 squared equals to 5 over 2 squared plus 1. So this would be 29 over 4. Right, so then I square root both sides. I will be left with x plus 5 over 2, which is equal to plus minus square root of 29 divided by 2. So x is therefore equal to negative 5 plus minus root 29 divided by 2. Let's look at the second method. The second method, which I personally prefer, is by using the formula, right? The formula for quadratic equations. And the formula for quadratic equations is just x equals to negative b plus minus square root of b squared minus 4ac divided by 2a. So let's solve for this same quadratic equation. So x would be negative 5 plus minus square root of 25 minus 4ac divided by 2. That would be negative 5 plus minus 25 plus 4 is 29 divided by 2. So you see, you get the same answer. Alright, next thing we'd like to do is to learn how to form quadratic equations from given roots. So let's say we are given two roots for this quadratic equation. So let's say there are two roots, x equals to alpha and x equals to beta. Right? How the roots relate to the quadratic equation is through this, this equation. So it will be x squared minus the sum of roots, x, plus the product of roots equals to 0. So the sum of roots, okay, given the roots alpha and beta, will just be alpha plus beta. The product of roots would be equal to alpha multiplied by beta. So if I rewrite this quadratic equation, it will be x squared minus alpha plus beta x plus alpha beta equals to 0. Okay, let's do an example together. Given that the roots are equal to 2 and negative 1, right? So the sum of roots, that's what you find first, will be just 2 plus negative 1, which is equal to 1. The product of roots will be 2 multiplied by negative 1, which will be negative 2. So then I can just insert that into the quadratic equation, which will be x squared minus the sum of roots is 1, so it will be 1x, and add the product of roots, which will be minus 2 equals to 0. So that is the quadratic equation, given the roots 2 and negative 1. Right? Lastly, we'll learn how we can solve for quadratic inequalities. Okay. So how can we determine the range of values of x that satisfy, okay, the quadratic inequalities? There are a few ways you could do this. The first way will be through graph sketching method. The second, using the number line method, or the table method. Okay, 3 methods. Personally, I like using the number line method. So we'll go through the number line method in this example. Okay, let's try to do an example together. So for the number line method, you have 6 plus x minus x squared is greater than or equal to 0. What I like to do is convert this into a quadratic equation. Factorize the quadratic equation first. So let's say this would be 6 plus x minus x squared equals to 0. Rearrange this, right, to be in the form of ax squared plus bx plus c. Remember, in this form, ax squared plus bx plus c equals to 0. So this will give you negative x squared plus x plus 6 equals to 0. And then factorize that. So what I like to do is I like to convert this. So this will be x squared minus x minus 6. I don't like a to be a negative value. So I change the signs of all the terms in the quadratic equation. Then I solve for it. So this would be plus minus 2 negative 3. So then I have x equals to negative 2 and x equals to 3. Then I draw a line, or horizontal line, and I write down the limits. So I have the limits negative 2 and 3. And what I like to do is, so for each, for the range of x less than negative 2, I like to find a value here, a value in this range, and a value here. So I need to find 3 values, 3 convenient numbers, okay, which I can easily insert into the function, which is 6 plus x minus x squared. Okay, to see whether the value I get is a positive or a negative value. So let's just do an example. Let's say I choose a value negative 5 here. Okay, any number that is less than negative 2. A number between negative 2 and 3, let's say number 0. And a number greater than 3, let's say number 5. So let's say if x were negative 5, I key that in. So this will be 6 minus 5 minus negative 5 squared. This would just be, okay, I don't need to know the exact value. I just need to know whether my final answer is a positive number or a negative number. From here, I can easily kind of deduce that this is going to be a negative value. Okay, how about if x were equal to 0? Well, if x were equal to 0, it would be 6, right? Just 6, which is a positive value. And if x were equal to 5, this would be 6 plus 5 minus 5 squared. I know that this is a negative value. So I rewrite that. I know that this is negative. Okay, so any number where x is less than negative 2, it will give a value, or a value which is less than 0. Any number between negative 2 and 3, it will give a positive value. And any number greater than 3 will give a negative value. So what are the ranges of x which satisfy these inequalities? So we want a number for this quadratic inequality to be greater than or equal to 0. So the range of values of x which satisfy this inequality would be x needs to be between negative 2 and 3, and negative 2 and 3 is included.